Good day everyone, I'm Carmela F. Ambrosio, and for this video, we're going to talk about one of the well-known mathematical game called the Tower of Hanoi. So first, let me give you some background information about this game. The Tower of Hanoi is a mathematical game or puzzle. It consists of 3 pegs and a number of different sized discs with holes through their centers, which can slide onto any peg. The discs are initially placed on one of the pegs with the largest disc on the bottom and the smallest disc on top, thus making a conical shape. And our goal is to move those discs from the left peg to the right peg. But in order to do that, we have to obey the following rules. First, only one disc can be moved at a time. Second, no disc can be placed on top of a smaller one. So at any point in the process of moving each disc, we are not allowed to move a larger disc on top of a smaller disc. Now, in this video, we will focus on solving the Tower of Hanoi problem in 3 distinct phases. First, using the step-by-step process, we're going to find the least number of moves needed to move the disc to the right peg. Second, we're going to investigate a pattern behind those moves. And the last one is, we will translate the pattern into a mathematical formula. So without further ado, let's get started. Let's try first on 3 discs. So sa problem na to, we have 2 options kung saan natin itatransfer yung pinakamalit na disc. It's either to the middle peg or to the right peg. So itry muna natin sa middle peg. Let's see kung ilang moves yung magagawa natin. But before that, while counting the number of moves, try to observe a pattern. So I highly recommend pausing the video and taking a second on your own to see the pattern. So now let's count the moves and observe. We have 1, 2, 3, 4, 5, 6, 7, 8, and 9 moves. So 9 moves yung magagawa natin if yung first move natin is sa middle peg. Now try naman nating i-transfer yung smaller disc sa right peg. And let's see kung saang peg yung mas konti yung moves na magagawa natin. Again, let's count. 1, 2, 3, 4, 5, 6, and 7 moves. So kapag sa right peg tayo nag-start na mag-transfer ng disc, mas konti yung move na magagawa natin. So for 3 discs, the least number of moves is 7. Now let's try on 4 discs. So again, umpisahan natin sa middle peg. Bilangin lang ulit natin yung mga moves. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15 moves. Next, for the right peg, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21 moves. So unlike sa 3 discs kanina, mas konti naman yung moves na magagawa natin sa 4 discs kapag sa middle peg tayo nag-start. So for 4 discs, the least number of moves is 15. Okay, from that process of moving na ginawa natin sa 3 and 4 discs, I observe a pattern, which is called the recursive pattern. So in order to find the least number of moves, first, we need to transfer n-1 disc to peg B. So if i-illustrate natin siya sa 3 and 4 disc, ganito siya. Next, transfer 1 disc left from peg A to peg C. So it looks like this. Then finally, transfer n-1 from peg B to peg C. So yan yung napansin natin na pattern. Yan yung process na kailangan nating sundan to find the least number of moves. Now, let's try to transfer that pattern into a mathematical formula. So, mag-start tayo sa isang list muna. For one list, we have m of 1 or move of 1 is equal to 1. And for two list, we have m of 2 is equal to 3. Next, for three list, as we can see, if ita-transfer natin yung n-1 or the green and yellow list sa middle peg, yung number of moves na magagawa natin is just like the moves of two list. Kaya ninote ko siya as m of 2. Then, another one move kapag transfer natin yung color blue na list from left peg to the right peg. And again, kapag transfer ulit natin yung n-1 list sa right peg, the number of moves na magagawa natin is same with m of 2. So, for n is equal to 3, we have 2 times m of 2, which is 3 plus 1. And we got 7 moves. So, same number of moves lang yung nakuha natin sa step-by-step na ginawa natin kanina. Next, for 4 list, dito naman, if ita-transfer natin yung n-1 list, yung m of 3 naman yung gagayahin natin na moves. And another 1 move para ma-transfer yung red list sa right peg. Then finally, another m of 3 na naman para ma-transfer ulit yung n-1 sa right peg. So for n is equal to 4, we have 2 times m of 3 plus 1, which is equal to 15 moves. And from that, we can conclude that m of n is equal to 2 times m of n-1 plus 1. So for this part, i-continue lang natin yung pagkuha ng least number of moves using our recursive formula. For n is equal to 5, we have 2 times m of 4, which is 15 plus 1 is equal to 31. Next, for n is equal to 6, we have 63 moves. For n is equal to 7, we have 127 moves. For n is equal to 8, we have 255 moves. And lastly, for n is equal to 9, we have 511 moves. So, ito yung summary of moves natin. But before we proceed, I have a question for you. Do you think we can find the least number of moves of 100 list using the recursive formula? How about the 1000 list? Think about it. So the answer is yes. Of course, mahanap natin. Pero may hirapan nga lang tayo. Kasi sa recursive formula, kailangan alam natin yung number of moves ng n-1. So kung yung n natin is 100, kailangan alam natin yung moves ng 99. Pero paano kung hindi natin alam? So, matatagalan at mahihirapan tayo. Kaya naman, for the last part of this video, gagamit tayo ng mathematical induction na kung saan mag-iisip tayo ng formula based sa mga nakuha natin na least number of moves from 1 to 9 list. At yung formula na may isip natin is ipoprove natin using mathematical induction. And ito yung magsisilbing general formula natin to solve the least number of moves of any n list, kahit hindi natin alam yung moves ng n-1. So using the least number of moves of 1 to 9 list, ang na-come up natin na formula is m of n is equal to 2 raised to n-1. So ino-note natin siya as our hypothesis. So paano nga ba natin nakuha yung hypothesis natin? So as you can see, yung difference ng m of n natin are 2, 4, 8, 16, 32, 64, 128, and 256. Which are equal to 2 raised to n, right? Now let's see the difference ng 2 raised to n na yan sa m of n natin. So 2 minus 1 is 1, 4 minus 3 is 1, 8 minus 7 is 1, and so on. So kung mapapansin ninyo, yung difference nila is 1. Kaya nag-minus tayo ng 1 sa 2 raised to n natin. So dyan natin nakuha yung hypothesis natin. Now let's try to prove this. For step 1, if n is equal to 1, let's see if yung makukuha natin na moves is 1. So isa-substitute lang natin siya sa ating hypothesis. And we got m of 1 is equal to 1. So tama siya. Nag-work yung hypothesis natin sa n is equal to 1. Next, for step 2, let us assume that for n is equal to k, it is true that m of k is equal to 2 raised to k minus 1. Then for our last step, step 3, show that for n is equal to k plus 1, 2 raised to k plus 1 minus 1 is equal to m of k plus 1. So, imamanipulate lang natin yung m of k plus 1 natin. So, papalitan lang natin yung n sa recursive formula ng k plus 1. Kaya yung m of k plus 1 natin is naging 2 times m of k plus 1 minus 1 plus 1. Then, mawawala si 1 minus 1. Matitira na lang yung 2 times m of k plus 1. Then, yung m of k natin sa step 2, isa-substitute lang natin siya dito. Then, manipulate lang natin. And we got 2 raised to 1 plus k minus 1. Which is equal siya sa ating equation sa left side. So, that's it. We can conclude now that we can find the least number of moves of any n disk using our formula 2 raised to n minus 1. So, that's the end of this video. Again, I'm Carmela F. Ambrosio and thank you for listening.